Okay, this is the P2 paper from October 2022. It's question number 7, which is an algebraic methods question. We're going to need to tidy up this algebraic fraction here. There's a little bit of work on the factor theorem when we get down there. And then there's also work on chapter 7 differentiation, because we're asked to find turning points. And turning points occur when dy by dx equals 0. Okay, let's have a look at the first part then. So the first part says we've got this fraction here that they want us to write in this form. So let's have a go at getting started with that. Excuse me. So part A says y is equal to 12x cubed x minus 7 plus 14x multiplied by 13x minus 15, that's the numerator, and the denominator has 21 square root x. So what I'm going to do, I know that I've got to multiply out the brackets, and I've also got to tidy up the root x. So let's do that. We get 12x to the 4 minus 84x cubed from that first bracket. We get plus 182x squared minus 210x for the second bracket. And instead of saying 21 root x, let's call that 21x to the half. Now, because I'm trying to write it in a new format, I'm going to do this really slowly. So I'm going to say, let's just break this fraction up into lots of different fractions. 84x cubed over 21x to the half. I'm just going to continue with that process all the way through then. So over 21x to the half, and finally minus 210x over 21x to the half. Okay, when we're looking at any of these individual terms here then, 12 over 21, that's easy. We can just simplify the fraction. That works out to be 4 over 7. And then if I'm looking at the powers here, I'm dividing powers. So dividing is the same as subtracting the numbers. So that's x to the 3.5, but we know that they've written it down as improper fractions. So they've written that one there for the first one. 84 divided by 21 is 4. And again, rather than saying x to the 2.5, I'm going to say x to the 5 over 2. And just follow that process through. So that fraction doesn't simplify down quite so nicely, but we get x to the 3 over 2. And the last one, 210 divided by 21 is 10, and that's going to be x to the half. So if we compare that now with a, b, c, d for our constants for writing it in that format, we've done part A. Part B then, what does part B ask us to do? It says that this curve has 3 turning points. So we talked about this already. Turning points means differentiate and put equal to 0. Show the coordinates of the turning points satisfy this equation up here. Well, I won't worry too much about getting exactly that yet, because I know how to get started with this. What I'm going to do is start with my equation, y equals, let's use the magic of the iPad to do that. Start off with that, and then all I'm going to do is differentiate, see what I get, and then I'll put that equal to 0. Let's just quickly talk about differentiating these terms. If I've got 4 over 7x to the 7 over 2, we're going to multiply by the power, which would be 7 over 2, take 1 off the power, so 7 over 2, take away 1 gives me 5 over 2, like that. This will then simplify down to 2, but I'm not going to do that for each one, otherwise it's going to take me way too long to do it. So following that process through, what we're going to get is, as we've just said, 2x to the 5 over 2 for the first one, and then multiply by the power, take 1 off the power, gives me minus 10x to the 3 over 2, multiply by the power, take 1 off the power, gives me 13x to the half, and minus 5x to the minus half. So as we said, at turning points, let's make it really clear to the examiner what we do. At turning points, dy by dx will equal 0. So that means 2x to the 5 over 2 minus 10x to the 3 over 2 plus 13x to the half minus 5x to the minus a half equals 0. Now, I'd normally struggle to try and solve an equation like this. This is fairly new for me if I've only just started past papers. But then we go back and we see, oh yeah, I remember what I was trying to get it to. I've got 2, minus 10, 13, and minus 5 as my constants there. And I've got the same numbers in this equation here. So I'm just going to focus on this last term. And if we focus on the last term up there, I want really that to be minus 5. So if I can transform that to become minus 5, when I transform that to be minus 5, the transformation should affect everything else. So if we're looking at this then, what we can say is, if I multiply by x to the half, I know that's going to sort out that last term. What does it do to the other terms? Well, 2x to the 5 over 2 multiplied by x to the half, add the powers, becomes x to the 6 over 2, or in other words, 2x cubed. If I do the same thing with my 10x to the 3 over 2, multiplying it by x to the half is going to give me x to the 4 over 2, which is x squared. Right, perfect. This is actually working out exactly as I wanted it to do then, that by multiplying all the terms by x to the half, both sides of the equation by x to the half, I actually end up with that, and that's what I wanted for trying to get it into the form, as it says there. Show the coordinates satisfy that equation there. Right, so that's nice and helpful for that part there. What does the last part say? It says, given that the x coordinate of one of the turning points is 1, right, what does that tell me? That tells me that x equals 1 solves that equation. Find, using algebra, the other two turning points. Okay, so this is what we were talking about right at the very, very start, that this now is going to be using the factor theorem. So what we can say is, and let's just make it clear to the examiner we understand, if one turning point occurs at x equals 1, then x minus 1 is a factor of the equation. So that immediately links me on to doing long division here. We'll have a quick talk about that in a second. Then what I'm going to do is to do algebraic long division now and see how many times does x minus 1 go into that, and that'll give me my other potential solution for the other two values of x that I need. So how do we do algebraic long division? Just a reminder to you, we're going to say, how many times does that x go into 2x cubed? How many times does it go in? It goes in 2x squared times. So I'm now going to multiply 2x squared by all of x minus 1. If I multiply that, I get 2x squared times x is 2x cubed. I get 2x squared times minus 1 is minus 2x squared. And then I'm going to subtract that. And when I subtract that, the whole point is that 2x cubed minus 2x cubed, that part disappears. Be careful, I've got minus 10x squared minus 2x squared. I tend to do that just to make it a little bit easier, and I'm less likely to make a mistake. I end up with minus 8x squared. At this point then, we just bring everything down there. In other words, the 13x and the minus 5. And that whole process that I've just been through, I now repeat 2 more times. Okay, we're not asking this time how many times x goes into minus 2x cubed, though. We're saying how many times does x go into minus 8x squared. Once I've done that, I know that that's minus 8x times. What did we then do last time? We multiplied that by x minus 1. If I multiply that by x minus 1, I'm going to get minus 8x squared, and then minus 8x times minus 1 gives me plus 8x there, and now I need to subtract that. When I subtract that, that becomes a plus, that becomes a minus. Just pause the video if you need to just make sure you're happy with that. Subtract it, take it away. 13x take away 8x gives me my 5x, and just like last time, bring that value down. And so I've just got to repeat this process one more time. And already, because I've done lots of these, I can see this is going to work. How many times this time does x go into 5x? It goes in 5 times. And when I decide that that's plus 5 there, when I now do that multiplication, what I'm looking to have happen is that I get 5x minus 5. Yeah, that's perfect, because I want to take that away and I don't want there to be any remainders here. So when I subtract that and I get 0 there, absolutely brilliant. What I've now shown is that 2x cubed minus 10x squared plus 13x minus 5 is the same as x minus 1, 2x squared minus 8x plus 5. So if I'm solving the equation 2x cubed minus 10x squared plus 13x minus 5 equals 0, it's the same equation as this one here. Equals 0. Well, I know that one of my answers is x equals 1. We've already done that. So now I just need to solve the equation 2x squared minus 8x plus 5 equals 0. So solving 2x squared minus 8x plus 5 equals 0. You could try and do it using factorizing, but I've done this already before, so I know that this one is much quicker and actually only solves using the quadratic formula. So solving that using x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Put your values in. X is equal to minus b minus minus 8 is 8 plus or minus the square root of. Just be careful when you're doing this bit. This is b squared minus 4, lots of 2, lots of 5, all over 2a, all over 4 in there, and then the solutions we get to those two are 4 plus or minus root 6 over 2, and so those are our two answers that we wanted, because it says find, using algebra, the exact x coordinates of the other two turning points, and that's what we've got by saying x equals 4 plus or minus root 6 over 2. Okay, hopefully that makes sense.